So, welcome to the Rockstart podcast about smart energy. This is Freerk Bisschop, Program Director at Rockstart, and I'm here with Kees van der Leun, Managing Director of Ecofys. Kees, good to see you. As you know, in Rockstart we're running accelerator programs to accelerate smart energy. You're daily busy with the climate issue. So for today I would like to talk to you about how these things get together, come together and work together, and explore the possibilities, limitations and needs there. But maybe you can start off and giving us an update on what currently is seen as the climate issue. What is at hand? How is it developing?
Thank you, Freerk. What we see is that climate disruption is already kicking in, and we're only at 1 degree of average warming. So we're very happy with the Paris Agreement to take action now to at least ensure that we stay well below 2 degrees and to aim for 1.5, which will make matters worse than they are now, but will at least avoid the worst. To get there, we need to take rapid action, especially in the energy system. So that's why it's very relevant to talk about the role of smart energy there.
Okay, but the problem seems to be accelerating. If I read the newspapers in the last weeks, are we heating up more rapidly even than we hoped for?
Well, there's two factors there. We have a so-called El Nino event, a global weather event that strikes every 5 or 10 years, which makes matters worse. There was a big one in '98, and that gave a peak in warming as well. But that's combined with stuff getting worse because we're still emitting a lot of CO2, and actually the emissions have even been growing. So it's like being in a bathtub with the faucet open and then turning the tap wider open instead of closing it. So the two lead indeed to quite significant climate disruption at the moment. We have very warm year, but we also see signs that the effects are possibly worse than the scenarios have set so far. We see, especially what worries me is the changes in the major atmospheric circulation patterns, the jet stream that drives our weather systems, changes in ocean currents, like the Gulf Stream that determines the climate here in Northwest Europe, for one, and the effects on the ice sheets on Greenland and the Antarctic that seem to be kick in earlier than we expected.
Okay, so it is a bit exaggerated by the El Nino effect maybe in the newspapers, but it's also a structural element there which really indicates that climate change is happening, and it's a real threat that grows day by day.
Yeah, sure. And people often say, well, what's so bad about 2 degrees? I mean, it's cold today, and 2 degrees warmer would be nice. It's not that temperature in itself, although it's also unevenly spread over the world, and it translates into maybe 5 degrees at the Arctic. But it's the system that we're disrupting, and that has major implications for weather in all parts of the world, and that's generally driving the weather out of the zone in which civilization has thrived, and generally creating problems for society.
Okay, so it's not just the temperature and not just the extremities in the weather. It's also driving population to other might be driving populations away from areas where they traditionally have lived and worked and got their food from.
Yeah. So even this morning I read about the Middle East and North Africa, where heating of a couple of degrees will make life much harder, which obviously increases the pressure to migrate and search for a new destination elsewhere.
Okay. And in what way is your company involved in all this?
At Ecofys, we're specialized in sustainable energy and and emissions reduction. So heavily involved in working on the solutions on the demand side, so in urban energy, in industries, on the system side, in energy systems and markets, and on the strategy and policy side, both in energy and climate.
Already for some time, I believe.
30 years, yeah. So I joined the company when it was actually a startup, although the word didn't exist at the time. No. I was the third employee in 1986.
It's always been about climate change from the beginning?
It wasn't the only factor and still isn't the only factor, because the energy transition has many benefits. For example, air pollution. If you make the transition from fossil fuel sources in industry and transport traffic to renewable energy, renewable electricity, you get rid of the air pollution as well, and it's of course a driving factor in many countries. Yeah. But even in our own cities in the Netherlands, it's still should be an important factor in doing this transition. But we've always been involved in just this topic of sustainable energy, and at least from 1987 on the climate change aspects of that.
Yeah. So when you started, actually the computer, the personal computer, was just occurring. So smart energy was far away, in the sense how we like to talk about it. Today, the internet, computing power, connectivity are everywhere. Something we look at from the perspective of energy and other sectors as well at Rockstart. What is your current understanding of how the internet has impacted or plays a role in climate change?
Well, I think that's only just beginning. I mean, obviously there's energy consumption attached to the use of the internet, and reducing the energy consumption of data centers is a big thing there. But I think the potential that can be unleashed to use these developments to work on the solution is only just beginning to be exploited. Mm-hmm. So we see some teleconferencing replacing physical transport, of course, which is especially very helpful for the long distance, but can also reduce traffic inside the country. We see some smart controls starting to reduce the energy consumption of systems, but there's a huge potential to be unleashed there.
Yeah. From what I gathered, the data centers are often pointed at as huge users, and that is true. I think about 6% of the energy used today, if I'm correct, is involved in from the electricity use in data centers. So it's a small country. All the IT, the whole cloud. But what I recognize daily is that there is a lot of progress in technology developments to take care of that, improving the overall efficiency, even using part of the energy that's now being lost in calculation, more or less, to use that more effectively by taking the heat from computers to heat buildings and houses, which is of course a good efficiency approach, and the overall way of using renewable energies for computing is really heavily adopted by the big guys like Google and Apple. So hopefully the contribution of the IT cloud in using energy will go down.
Yeah, sure, and there's we're talking to several of the big guys about the opportunity to use excess renewable energy production for their operations, because they generally have data centers around the world, and they can shift loads from one data center to the other. So they could actually provide flexibility in the global energy system if they take that into account in their load shifting algorithms. So for example, if there's a lot of wind in Europe, they could shift loads to Europe and have their operations there run at 100%, and in that way effectively help integration of large shares of renewable energy.
Yeah, okay, that's good to hear. So that the greening of energy use in IT is something, but at Rockstart we love to look at new initiative and entrepreneurship, which is really focused on using IT to really improve our daily use and application of renewables. I'd like to spend a few words on that to see what you see there, but we think that a lot of energy is being lost because we are so unaware of where and when we need energy, and we are spoiling it. And we do see a lot of development in the startup world of companies that connect the information, the general information about the weather, but also information about who is needing energy and who's having a surplus at a moment in time, so real-time information, and use that to optimize production of energy, when it's renewables especially, but also the use of energy, when to avoid that some process somewhere is using energy to create heat, whereas another has a surplus of heat that's only a few meters or hundreds of meters away that could be used to tap from. In tapping the potential of efficiency, I think there's a huge need for interactivity, connectivity, and exchange of information. Do you agree?
I fully agree. When we analyze what it would take to get to a sustainable energy system, the energy efficiency part plays a big role, because if we let energy demand in the world grow in sync with the economic growth that is desired, especially in the emerging economies, then it's really hard to solve the equation. But fortunately, a lot of the energy is still wasted, so there's a huge potential to do it better in terms of efficiency. And we think it's possible to increase efficiency worldwide by 3 to 4% per year, and thereby keeping the demand flat, which makes it a lot easier to fill it in with renewables. If you want to attack that, you have to look at the real demand. So we always say there's not really an energy demand. Nobody really wants a kilowatt hour or a cubic meter of natural gas. There's a demand for energy services. And if you start from that, what you have to look at the useful service. So any type of lamp burning in a room where nobody's present has a system efficiency of 0%. Whatever, whether it's a LED or whatever. But the trick is not to have lamps burning where nobody's present. Yeah. And that's just a very simple example, but if you look at that throughout buildings and industry and transport, you'll find tons of examples, and you'll find that at least 50% of all electricity consumption is used.
Well, I can give you such a very practical example from the current batch of startups that we're working with, which is an Italian startup that builds or transfers the lights in public lighting and big spaces with LED, but they also, while doing that, they also integrate a smart connectivity device behind that, which allows all these lamps to communicate between one another in a mesh network, and also provide a communication network with their environment. So this allows people, more or less, or users, to be in contact with the lights, and the lights will follow them wherever they go, because the lights themselves can send the messages and provide a parallel infrastructure to optimize the usage of energy. And it also creates a platform for further services like emergency lighting or detection of pollution, etc. So it's indeed a layer of infrastructure that creates also a platform for smart communication and smart usage, which would also save a lot of energy.
Yeah, I really like that example. It's not only the energy part, it's the co-benefits that are stressed. I think we need integral solutions.
Mm-hmm.
I think for many people the climate change is a looming risk in the distance, but not a daily concern. So in terms of strategy, it's very important to address various topics at the same time. And the example itself, I'm longing to see that applied to many places nearby.
Mm-hmm.
For example, the Utrecht University nearby here has a huge parking lot with lamps burning on the whole parking lot, hundreds of lamps all night, 24/7.
Yeah.
And rarely anyone using the parking lot at night. So of course, if someone's there, there should be light, but not at all other times.
Mm-hmm. Yeah, so there's a lot of room for optimization.
Yeah, I guess they're taking the 12 hours of the night. I guess you could save 99% by such a system.
Yeah.
Which translates to 49 over the whole year.
Yeah. I'm glad you recognize that, because as far as I'm informed, the overall efficiency of the whole energy system is well, even below 15% or so, and we might as well get to 50% if we really do our job properly. So there should be a lot of potential in making better use of the existing technologies and infrastructure. And I don't think we have to invent a lot of new technology to apply to solve the climate issue there. Or do you think that new technologies need to be invented to solve our problems there?
No, we can do it with the technology that's on the shelf right now. Of course, new developments are tremendous help in reducing the cost and increasing the co-benefits. So they will increase the acceptance of those solutions. Mm-hmm. But technically and economically speaking, the technology is there. It's how to implement it.
Yeah, and we're being helped by the fact, I think, that the cost curves of renewable energy are impressively, you know, how solar energy and wind energy come down the hill in consistently over decades now, and even seem sometimes to be accelerating that path down in terms of cost. It's the same thing with the cost of sensors and connectivity, and fortunately also the new protocols of communication between those sensors and our networks has become very efficient with Bluetooth, low energy technology, etc. So I do believe costs are coming down and energy efficiency is going up there in terms of generating clean power and being able to use it in a much more efficient way.
Yeah, that's really good news.
Yeah. And you guys at Ecofys, you also make scenarios into the future, right? Quite a bit. So to help policymakers to set their policy measures, and also industries to identify roadmaps. What I'm curious about, if say 2050 is the year that we need a zero emission society in terms of carbon emissions and global heating, is this achievable in Ecofys' view, and what is your current understanding of what is needed to keep our climate safe?
Well, is pretty much on the mark. So to comply with the Paris Agreement, we think that the emissions from the energy system have to go to zero before 2050, latest 2050, preferably sooner. And even then you might need so-called carbon dioxide removal. You might need to pull back some CO2 from the atmosphere, but you wouldn't want to rely on that too much because it's not there yet, and it will cost a ton. So we have to get the emissions from the energy system down to zero before 2050. It's achievable. We've done the analysis in a report with WWF in 2011. It's called the Energy Report. It's freely available on the internet. And that already has the broad picture of addressing this energy efficiency, starting from the real demand side, and then in that way keeping global energy demand flat in spite of economic growth, and then filling it up with renewables. And that's not undoable. It's affordable in the end, but it requires taking a huge leap. That reasoning is still valid. Some parts have become better, like the cost of solar and wind that you referred to, but we're also 5 years down the road. So we now only have 34 years left or less. That means that it's all about making speed now. It's about accelerating. And that means that getting there involves using any momentum that is already there in society. Forget about taking a blank sheet of paper and drawing the ideal path to zero emissions. Look at developments that have momentum, such as the ones in smart energy that you just described, and fully deploy those.
Yeah. And does that involve changing the rules of the game and really disruptive changes in the energy industry itself, you think?
Yeah, that's already happening, but that should actually be reinforced because it's still very bad that it's almost free to emit a ton of CO2. Whereas we know that it at least costs damage of like €50 or $50, that order of magnitude. It's in many parts of the world it costs like 0 to $10 or euros per ton to emit it. And that's a major market distortion that should be taken away, and it will accelerate the transition a lot. But even with this artificial cheap emissions changes happening, the rapid advance of solar PV, for example, makes life really hard for the operators of so-called baseload power plants.
Yeah.
And that means that investments in new baseload power plants are dramatically down. Yeah. So it's already taking place even in a distorted marketplace.
Yeah, we also see that in how big players like the German world players like E.ON and RW are restructuring their business and rapidly adopting, embracing new companies, new entrepreneurs to come to work with them. As we do in Rockstart, we work with utilities and connect them with our smart energy startups and entrepreneurs. And we also see how valuable that is for both sides, because it allows startups to test their ideas against the existing order and way of thinking. So it's a way of validating what they're doing. And on the other hand, we see those more progressive industry players to look into a world and a way of operation and a way of thinking, also including different business models and revenue models, to apply technology to change their whole business ultimately, which would obviously harm their existing traditional way of working. So it creates friction in their own companies, but they do start more and more to adapt and embrace these developments, and try to include them in their organization, and thereby also importing some of that thinking in how to make more agile use of infrastructure and energy sources, get them into the culture and thinking of their strategy, ultimately, hopefully as well.
Yeah, but it's out of necessity as well for them, for the big utilities, because they don't get capital anymore for their old business model.
No.
You can see that the share prices have gone down dramatically,
Mm-hmm.
and it's not possible for them to attract any more capital on the old road.
Yeah.
So if they want to safeguard their future, they feel the urge to get involved in these new technologies for the simple reason that they want to still be there in a couple of decades.
Mm-hmm.
That's also the background to some of those restructurings that you mentioned.
Mm-hmm. Yeah. So do you see? Let me ask you. I'm curious to see what you in your analysis of how to bridge the gap to a zero zero emission society. What are the crucial elements, and what do you think is the role of internet and connectivity in those?
Well, you have to start then from this real demand side. So you have to look at buildings, industry, transport.
Yeah. But how big is that chunk? How much? If we would try to scale the percentages of the big chunks of things that we need to do. Can you give a kind of a breakdown?
Yeah, it's roughly a third and a third and a third over buildings, industry and transport.
Okay.
It differs per country. So some countries have a lot of transportation and then the transport may be 40%. Some countries don't, and then the buildings may have a larger share, but this is roughly the share. So you should always keep all of them in mind. Sometimes people get excited about developments around homes, which is very exciting, but it's only a third of the puzzle. So also focus on solutions for industry and focus on solutions for transport, and then you have pretty good coverage. And in all three sectors, it's about looking from the real demand upwards. So how can I do that with as little material input as possible? How can I produce the materials with as little energy input as possible? How can I run my operations in a very energy efficient way? Some of those will have to be regulated and thereby give a strong incentive for end users to do something about it. But then that creates a marketplace as well, and that's where solutions come in. Everybody for some reason or another should want solutions, and then there should be a good marketplace that allows innovative solutions to help out there. So on the buildings, it's about, there's again a breakdown. It's about smart heating. It's not only electricity, but heating can be done electrically with heat pumps or in a hybrid way to make sure that there's not huge demand peaks in a cold winter week. There's of course your lighting, your appliances. With transportation, it's passenger transport, so it's the cars, maybe electric vehicles running on renewables, maybe shared electric vehicles that drive in trains to reduce air friction. But there's also air traffic, which is sometimes still escapes scrutiny. There's, of course, the cargo part, a lot of shipping, a lot of trucks. Would be much more efficient to do more with public transport, with electric rail for cargo transportation instead of putting it all on trucks and clogging our highways. And then in industry, you have to dive down into the individual sectors. So we'll need some cement, we'll need some steel, we'll need some aluminum, but there's also many other less energy intensive industries, and for all of those you have to develop dedicated solutions to do stuff with much less energy input.
But from the last one, the industry, there's this great example of a Czech startup company that we're working with currently that are proving that they can aggregate the different process controls in medium-sized industries. Well, now that you say about the industry, I have this great example of a Czech startup company that we're currently working with They are aggregating the controls of different processes in medium-sized industries in one environment, because they often controlled by very many individual controls, and they were surprised actually themselves that this created energy savings between 40 and even 70% in a factory, by just combining that information in a way that it could be avoided that machines were working against one another. And we don't even need to find new technologies to make concrete. We can, if we would apply this on a large scale, which can easily be done by just connecting things that are already there. I'm hoping and expecting that we could really accelerate based on what is already there, and just making sure that we set up a rapid scaling of that service, software as a service solutions.
Yeah, that's an excellent example, and it sounds scalable. I mean, you can scale up a lot quicker with these kind of control systems than when you have to replace all kinds of hardware that hasn't been depreciated yet, etc.
Yeah.
On the other hand, you can also add that on top of your better system control. Of course, if in course of time you're also able to make the motors in that factory more efficient by applying better motor drives, etc.
Mm-hmm.
You can have maybe 50% reduction from the control side, and then another 50% on the remaining 50%.
So yeah, exactly. By following the energy flows, there also gets information collected about the status of the equipment, and whether it's going into failure or whether it's not operating decently, or what is their efficiency of operating against the standard technology available today, and thereby steering also clever replacements.
Sounds really good.
Yeah, it's a nice development.
And good to hear that there are startups focusing on the industry side as well.
Well,
you
yeah, sure.
mostly hear about the home side, and
the home side is attracting a lot of attention. Of course, it's very connected to how people live.
Of course, and it's great.
And it's a huge potential, but I do agree we need all. Although there are some nice examples there too to share maybe. Because we do see an increased take-up of smart home systems. If we look at how Google and Amazon are also allowing a much friendlier interface to occur between people in their homes, and ways to talk to a device that takes control and executes commands and includes that with some intelligence. I do expect that we'll see a lot of things happening. A nice example of how some of the guys that we work with already tap into that future is saying, well, listen, if we are starting to be able to control the devices in a house, then why don't we make use of the fact that you can choose whether you switch on your not only your battery, but also your heating equipment or your cooling equipment at what point in time. And if you're able to control that and switch that on and off more flexibly, this would avoid a lot of problems that currently the grid operators have in maintaining the power quality in the grid. For which they still use the conventional large coal-fired or fossil fuel-fired power stations, and if we can avoid that would create tremendous value that could be given back to people that run their home system, and actually create a revenue stream if they connect their smart home to the grid and sell their flexibility to the grid operators.
Yeah, for sure. And it's very important that you mention that, because it's often the challenge is raised that using more wind and solar will pose on the grid, and then the question is, how can we solve that? And often old-fashioned large-scale solutions pop up, like we should have major storage schemes.
Mm-hmm.
But a lot on that side, the flexibility side, as we call it, a lot can be done in a decentral way as well.
Mm-hmm. Yeah, I'm glad you recognize that. And I'm also curious to hear your view on how we can even involve transaction mechanisms based on blockchain technology, that is the technology used for bitcoins and the other virtual currencies, to allow peer-to-peer sales and purchase of energy on a very local level.
I've seen a lot of buzz around that lately, but to be honest, I had to read up on that because I don't fully understand yet what role that could play. But it sure sounds like something that could be of interest.
Well, this is a development indeed that is buzzing and rapidly gaining momentum. We see quite a few startups at the forefront of that, even producing currencies based on the production of energy. So for every megawatt hour that is produced with renewables, they would bring a solar coin or something into the market. But even before going there, I do see that if we want to effectively allow people in a local grid to trade their excess energy that they produce with their solar power and don't need it with their neighbors or with the electric car in the neighborhood, the blockchain technology really may help to let that transaction happen in a safe and reliable and very cheap way without having to measure flows of energy, collecting them in a administrative system,
Central
in a utility, in a clearinghouse, and then back again because that would not even be near time. Blockchain technology really would allow real-time transaction payments to take place and micropayments in a safe and reliable way, and it might even lead to us wondering whether an energy meter is necessary in the future.
Sounds exciting.
It's exciting stuff.
Looking forward to dig into that.
Yeah, well, let's talk about that some more in another stage. I'm looking forward to see you guys helping the world to understand what the path is towards a zero society, and we'll keep working on accelerating promising startup that may make that happen with entrepreneurship and collaboration with the existing industry.
That's the deal.
Okay, let's do that. Thank you very much for this talk. It's been very nice to get up to speed with this stuff.
Thanks, Freerk.
Thanks, Kees.